Hello, we are Alpha One, and our project is a motion controlled robotic arm, which is sponsored by Professor Milos Zefran. Our team, as shown below, consists of Lohith Muppala, Ali Kazmi, Stefan Mijalkov, and myself, Joshua Zychal.
The objective of our project is to design a software for easy interaction between the user and the robotic arm. The idea behind this is that the user will train the robot to follow certain path using HTC Vive motion controller. The main benefit of having such system is that our design allows for user to have little to no technical knowledge. This is a cost-effective way to introduce programmable robotic arms to the everyday industry.
For our main design, we are using a gaming controller as an input device. The data collected from these devices are then processed by the function which are created in ROS. The function are then executed by R17 robotic arm through a processing device called K11R robotic controller. The gaming controller that we are using is called HTC Vive controller. It uses a lighthouse system, so the controller detects its position using an infrared light, which is why it is faster and energy efficient. As compared to our other option, it is cheaper and user-friendly because of its simple and straightforward design. The processor that we are using is called K11R robotic controller. The controller is compatible with a wide range of ST robotic arms, and it is readily available to us with R17 robotic arm. We have set up a GUI interface. It shows the state of the system and has the user guide which explains the operation of the Vive controller. User has also option to stop and run the system through this GUI. One of the major changes that we made in our design was to create the function using Python and RoboForth command line instead of ROS configuration. The change was mainly because of the compatibility issues that we were having between ROS operating system and Windows operating system. It made it nearly impossible to publish Vive coordinates in ROS MoveIt application.
Coming to our design overview, this slide gives a high-level explanation of our general design. The user utilizes the HTC Vive controller system to input the coordinates into the Python script. The script collects, processes, and then sends these coordinates to the robot controller, where the K11R controller processes the information for replication. Additionally, we also have a GUI that makes the whole program interactive and user-friendly. We implemented our project with two main functionality modes, teaching mode and replication mode. The teaching mode primarily collects all the necessary information needed for the replication. The main inputs for the function are the coordinates, orientation, and the accelerometer data. The outputs are text files where the information is collected. The teaching mode also has fine-grained and coarse-grained sub-modes that control the robot incrementation depending on the distance from the object. When the robot is closer to the object, we implement fine-grained mode, which is smaller movements and slower speeds. The replication function reads the information from the text file, calculates the displacement, and sends the information to the K11R robot for replication. The robot controller controls the motions via drive modules that control the robot motors accurately. Both replication and teaching mode support an emergency button that will be further explained by Josh in our GUI video.
So here we're going to be explaining through our GUI, and first things first, we're going to hit run program, and our GUI immediately pops up. The first thing that's going to show in the terminal is whether or not the connection between the Vive controller and the Vive base station is there. And as you can see in the terminal, it says connection ready. So therefore, you are good to go. Next, I'm going to set the COM port, which is going to be, we'll just say COM port 3. And that's just for purposes of where USB is connected so the ARM can be connected to your actual computer. And then once I go to the help guide, this is a help guide we created just as like an instruction tool for the user to have. Just as a reference while they're using the ARM, it goes through all the buttons and explains all the buttons and what they do on the actual controller. So as you can see here, the Vive controller has many buttons here. The ones that we are utilizing are the menu button, the trigger, and the grip button. The menu button is going to be the start of the program. It's going to initiate the start of the program. So before you hit the menu button, none of the other buttons are going to react to anything. So you may have to make sure your robot is in a safe position before you click start on the menu button. And once you're in the menu button, you have two different options you can do. The grip button is going to change between replication mode, fine grain mode, or teaching mode. And once you're in any of those, the trigger is going to switch between the axis, whether X, Y, or Z. And as you can see, as I scroll down here, here's a little bit of an explanation as to which buttons are doing what, just in case you have just so the user has some reference to go back to, in case they don't actually know what is going on and which buttons to use. Here it explains exactly what I just said about menu, grip, and trigger button, and replication mode. So as I exit out of the help guide, I'm going to click Run Program. And once I hit Run Program, the program is going to start collecting coordinates. And it's going to ask first whether or not you are going to click the menu button, which the menu button, as I stated before, is going to start the collection process. As you can see here, we are now in displacement of X. This is the X-axis. And as you can see, we used a print statement to correct some errors in some of when communicating with the Vive. When the displacement is too small, the robot will not take it in. And when you click the trigger again, it's going to switch to Y. And as you can see, it's collecting Y movements, and I'm moving the Vive controller up and down. And it collects different coordinates here. And if you click the trigger again, it is going to transition into the Z movements, which is forward or backward. And it's going to do the same thing with the displacement of Y too small, and collect some coordinates, and some it's going to skip over here. And when you're done doing that, you can hit the grip button again, and it will save all the coordinates and all the major points that you need to save for the arm to replicate. So once you click save here, it's going to output the certain coordinates, which is going to prepare us to input those coordinates into the robotic arm to replicate those motions, whichever you may have done. And so going back to the GUI now, we are going to hit the stop button. And the stop button is going to exit the program, and it also acts as an emergency stop button in case the arm is getting into an unsafe position.
In the following video, we will demonstrate the functionality of our system. The first thing I will do is turn on the system by pressing the menu button. After the system is turned on, I will use the grip button to switch the system to teaching mode. First, I will demonstrate how the teaching works. Once the teaching is done, the arm will memorize the key points and replicate the learned path. The system is currently on, and I will switch to teaching mode. Now I will move the Vive controller to my right. As you can see, the arm follows my movements. I will change the axis to Y and move the Vive controller up. The arm followed my movements in Y direction, neglecting the small displacements in the other axis. Finally, I will move the Vive controller to my left and then down. The arm will follow and memorize the path. The system is capable of memorizing many different paths. When prompted, the arm replicates the lastly learned path. This gives the user an opportunity to visually see how the arm replicates and decide if they want to save or repeat the process again. The teaching is now complete. I will use the grip button again to switch to replication mode. The arm will first go to initial home position, and then it will replicate the learned path.
In this video, we'll explain one of our test cases, which is demonstrating of the robot to follow the point A to point B movement.
To conclude, we have a couple of fun videos that we created for various different tasks. On the left here, we have a video in which we did for a mock COVID test for Professor Alan Feinerman, and on the right was just a high-five video that we created. At this point, we can take any questions that there may be, and thank you very much.